Okay, this is our waves and sound study guide. Okay. We looked at this graphic in class actually yesterday. So this shows us the parts of these two types of waves. Sorry, my printer is printing. It's almost done. So this is a longitudinal wave. This is the wave that's kind of like a pulse. If you remember, we did it through the slinky, and I kind of gave it a push, and so then you've got these areas that bunch up, and then these areas where it's more spread apart. The bunched up areas are called compressions, and then the spread apart areas are called rarefactions. And then with a longitudinal wave, it has a wavelength, just like our transverse wave. You can measure it from compression to compression. Compressions are kind of similar to the peaks of a transverse wave, and rarefactions are similar to the valleys. So this is wavelength. And then a transverse wave is longitudinal is where the particles vibrate with the energy transfer in the same direction as the energy transfer. They're parallel. Transverse is where it's perpendicular. You've got a vibration that's going up and down, but the energy is going like this way, so they're perpendicular to each other. And this is more, what we would think of as our traditional wave type, I guess. Parts of this wave, we've got our peaks, our top points, our valleys, our low points. Our amplitude is our max distance here from this center equilibrium line. And then wavelength here. Here it's shown from peak to peak. That's this length of the waveform from one peak to the next. You could also measure it from one valley to another, or you could measure the length of one complete waveform, like from here to here. All of those will give you the same thing. What's the difference between a mechanical and an electromagnetic wave? What are some examples of each? All right, so mechanical requires what we call a medium or a material. So these are waves that have to travel through a solid, a liquid, or a gas. Okay. And examples of these would be like sound waves, which we've talked about a lot. Water waves, like the ocean waves, they travel through water. A jump rope type wave. Okay. Electromagnetic waves, which we'll talk about after spring break, which is coming up soon. These can travel through a medium or a vacuum. Okay. So they can travel through space. They can also travel through material, but they can travel through space. And so examples of those are like light waves, radio, X-rays, and we will learn all about those after we come back from our break. So, difference between transverse and longitudinal wave. I kind of talked about this already. All right, so here are the vibration of particles is perpendicular to energy transfer. Examples of transverse waves, again, water is a transverse wave, a jump rope. And then longitudinal, the vibration of the particles is parallel to the energy transfer. And our big example of that one is sound. Okay. And then we've got this table. So this is kind of talking about what we just said, but examples of waves that are mechanical and are transverse are going to be waves on a rope or water waves. And I'm just picking from the list here. Examples of electromagnetic and transverse waves are going to be light, radio, gamma rays. I got one here. Waves that are mechanical and longitudinal, sound. That's our big one. Earthquake waves actually are also a mechanical and longitudinal wave. Just as an FYI. There are no electromagnetic waves that are longitudinal. All electromagnetic waves are transverse. And we'll talk about that again more, like I said, after spring break. But do waves carry energy or matter? So waves transfer energy and not matter. They're a transfer of energy. The matter gets moved as through the process of the energy transferring, like it gets displaced. If you've got ocean waves, the water's being moved by the energy of the wave, but that is not the wave. The wave is actually the movement of energy. Okay. So it's just kind of a byproduct, I guess, of the energy. Okay, let's see. I think I can do a few more in this video. So, of the following materials, through which would a mechanical wave travel fastest and why? And so we're thinking about sound waves here. Okay, so sound waves travel fastest through solids, and then liquids, and then gas, because sound waves use molecules to travel through, and so if they've got a denser medium, then it's easier for them to travel, so they'll travel faster. So they would travel fastest through, let's see, of these choices, steel would be the fastest because that is a solid, a dense solid. Okay. And then I think foam would be next. Foam is also a solid, but it's not as dense. Think about foam. It's got all those holes in it. And then water would be third because it's a liquid. So water's still got molecules. They're just more spread out. Air would be fourth because that's even more spread out. That's a gas. And then vacuum would be last. Actually, a mechanical wave can't travel through a vacuum because there is no material. There's no molecules for it to bounce off of. So, okay, let's see. I'm going to pick up with the next video.